Section 1.4, shifting, reflecting, and stretching graphs. These are 6 basic functions that you should have an idea of what the graph looks like without having to plug it into your calculator or plot points in the coordinate plane. You should know these 6 general shapes and what the functions look like. First one, y equals a constant. You should know that y equals a constant is always going to be the graph of a horizontal line. Line y equals x, you should recognize again that this is a linear function. The graph y equals x splits quadrants 1 and 3 diagonally in half. Absolute value graph, when we have a linear function inside an absolute value, it will always be a V shape when we look at the graph of that function. Square root function looks like a half of a parabola opening to the right. Quadratic function, you should know, is parabola shaped. And finally, a cubic function has that general shape. And what we're going to be doing today is we're going to be talking about these 6 general types of functions and how, when we add things, subtract things, put coefficients on them, how that is affecting the look of our overall graph. So the first shifts we're going to talk about are vertical and horizontal shifts. If I have a new function h of x and I am subtracting a value directly from x in our equation, that is going to be a horizontal shift, c units to the right. So notice we go the opposite sign. So down here in the second one, h of x equals f of x plus c, still going to be a horizontal shift because I'm adding or subtracting directly from x, so that should tell you that you're shifting along the x-axis. Now it's going to be those c units to the left. So you shift the opposite number of units. Now in 3 and 4, notice we're adding or subtracting a constant from the entire function. Remember our function notation, f of x replaces y. So here this is like y minus c, so I'm subtracting it from the y. That tells me that we are going to then move vertically. But you do not move the opposite number of units when it is a vertical shift. So if it's minus c, you go c units down. If it is plus c, you are going to shift c units up. So the key distinction is, where am I adding or subtracting the value from? In the first two here, we are adding or subtracting directly from x. In the second two, we are adding or subtracting from the entire function f of x, which remember replaces y, so that's going to tell you the direction of the shift. If it's added or subtracted directly from x, shift left or right along the x-axis. Added or subtracted from the whole function, shift up or down along the y-axis. Reflections. Again, notice where we are putting the negative sign. If we put the negative sign on the entire function, that is then going to be reflected over the x-axis. If I put the negative only on the x portion, now we're reflecting it over the y-axis. Again, that should make some intuitive sense to you. If I'm taking the opposite of all the y values, well, if the y values were positive and now I take the opposite of them, it's going to reflect it over the x-axis. Likewise here, if I put the negative just on the x's and all my x values were positive in quadrants 1 and 4, and they now become negative, I'm reflecting it over the y-axis into quadrants 2 and 3. Last thing we're going to talk about is stretching and shrinking a function. We add a coefficient on the entire function. If that coefficient is greater than 1, then the graph is going to be stretched vertically. And this will make more sense when we look at some specific examples. If that value of c is between 0 and 1, now the graph is shrunk vertically. So if I look at, Let's look at 3 different parabolas here. First, look at y equals x squared. Again, this doesn't have to be accurate, your sketch here. Let's say that that was a graph of y equals x squared. Well, now let's add a coefficient and say, well, what's y equals 4x squared then going to look like? Well, we know that 4 is greater than 1, so the graph should be stretched vertically. So if you can imagine me holding this parabola down here at the origin at 0, 0, and then somebody pulling on each one of these ends to stretch it vertically, what's going to happen to the parabola? Well, it's going to now become much narrower because we're pulling on those ends, which is going to bring it in. Likewise, let's say that we have y equals 1/3 x squared. Now, if I have that graph, I know 1/3 is between 0 and 1, so our graph should be shrunk vertically. So again, we're relating it back to the graph in red here of our original graph, y equals x squared. Again, if we hold it down at this point, and now I am shrinking or pushing down on the ends of this, what's going to happen? Well, if I push down on the ends, it's going to come out here and be much wider. So there's how those 3 graphs would be related based upon the different coefficients that we add out in front of our function. Okay, explain how g of x and h of x are related to f of x. And this is exactly what you're going to be doing in the homework. What I want you to do in the homework is simply write statements, just like we're going to write here in the notes, that explain what is going on from one function to the next. So in this case, how are g of x and h of x related to f of x? Well, start with g of x. G of x is the same as f of x, but not quite, because we're doing 2 things to it. What are we doing? Well, first of all, we added 2 to it. Were we adding 2 just to the x, or were we adding 2 to the x squared? Well, we were just adding it to the x, and how you would see that, or what the difference would be, this is what it would look like if we were adding 2 directly to the x. We didn't. We added it to the entire function x squared. So that's adding it to y, remember. The whole function is represented f of x by our y variable. We're adding 2, so that means we are shifting it 2 units up. And that coefficient of 1/4 is then also going to shrink it vertically. So g of x is f of x shifted 2 units up and shrunk vertically. H of x. Again, we're relating it back to f of x. So h of x is f of x. And now the only thing we've done 2 things here to h of x. We haven't added or subtracted anything. So that means we're not shifting it at all. But what we did do is we added a negative out here in front of the entire function. And we had that coefficient of 1/4. So don't think of the coefficient as being negative 1/4. Think of the coefficient just being the 1/4, and then the negative, remember, reflects it. So first of all, the 1/4 is going to shrink it vertically. So h of x is f of x shrunk vertically and reflected over the x-axis. So that's exactly what I want to see in the homework too. You don't need to graph things. If you want to check the graphs on your calculator to make sure your descriptions are correct, would not be a bad idea. But I do not need to see the graphs. I want to see the written descriptions just like we did here. Letter B. Same type of thing. Start with g of x. G of x is f of x. Only thing that's been done to g of x is we've added a coefficient of 2. That coefficient is larger than 1. Since it is larger than 1, that means g of x is f of x stretched vertically. H of x is the same as f of x, but we've done all 4 different transformations now. We've added or subtracted something directly from x. We've added or subtracted something from the entire function. We added a coefficient, and we added a negative sign. So we have 4 different transformations being done here to h of x. Let's start with our shifts. Adding the 2 directly to x, remember, since we're adding it directly to x, is going to shift it along the x-axis. It's the opposite number of units, so h of x is f of x shifted 2 units to the left, and subtracting 1 from the entire function, 1 unit down. So h of x is f of x shifted 2 units to the left, 1 unit down. The 2 in front is going to stretch it vertically. And the negative reflected over the x-axis. Letter C, going from f of x to g of x. G of x is f of x. Coefficient of 1/2 now is between 0 and 1, so it's going to be shrunk vertically. So g of x is f of x shrunk vertically. H of x is f of x. 3 transformations done here. We're adding something directly to x. We have now a lead coefficient, and we have a negative sign. So h of x is f of x. Let's do the shifts first. Shifted 4 units to the left. The 1/2 shrinks it vertically. And the negative reflected over the x-axis. Okay, the last 3 I want to look at a couple of the even ones out of the book. So follow along in your books on page 49. We're going to look at problems 22, 24, and 36 together. Let's start with problem 22. Y equals the square root of x plus 2. So how is this related just to our standard square root function? Our new function f of x would be shifted 2 units. And now what direction? Well, we're adding 2 to our entire function of the square root of x. So that's shifting it up or down, in this case, up 2 units. Y equals the square root of x plus 4. This time, notice that we are adding the 4 directly to x. So now that's a horizontal shift. So it shifted 4 units to the left. Our final one here, looking at 36. H of x equals -2 times x minus 1 cubed plus 3. Now here with this one, we have all 4 transformations. I have something added or subtracted directly from x, something added or subtracted from the whole function. I have a new coefficient on the whole function, and I have a negative out front. So we need to account for all 4 of those when we do our written explanation. H of x is f of x shifted 1 unit to the right, 3 units up, stretched vertically, and reflected over the x-axis.